Here we go, last trig lesson. Isn't this stuff easy? So we're going to learn about angles of elevation and depression. And of course you're still using SOHCAHTOA, and the important thing here is going to be that you do label them correctly. Once you do, it's going to be a problem you already know how to work from previous lessons. So let's take a look at it. Please copy this picture in your vocabulary, and after you copy that, please pause it, get it copied, and then afterwards listen to the few things we're going to add to it and draw this in. Notice that the angle of depression swings down from the horizontal line, and the angle of elevation, because depress means down, elevate means to go up, it swings up from the horizontal line. And more importantly, notice that these angles are like in the Z, so they are alternate interior angles. We've learned about that. And because of that, they are equal. They're congruent angles. So the cool thing about this is if you drew in a full triangle, if you turn this picture into a full triangle right there and right there, then those are two congruent triangles, and you could use either one of them. You could use either one of those triangles to find the missing information that you need, because obviously this length would be the same as across the bottom, and this length would be like a height in a picture would be the same as that height. So it's up to you whether you use actual angles of depression or elevation, because they are the same. Where people get tripped up is an angle of depression always comes down from the horizontal line, comes down from it, and people screw up by putting that number here instead, which would not be the same. So let's look at some. Okay, so the other thing that gives some people trouble is drawing the picture, so you've got to get good at that. So let's draw this picture. It'll always be a triangle. The height of a tree is 15 meters. So here's my tree, 15 meters. To the nearest whole degree, what is the angle of elevation of the sun when the tree casts a shadow? So here's my shadow, and here's my triangle. So what is the angle of elevation of the sun when the tree casts a shadow that's 9.3 meters long on level ground? So the shadow is 9.3 meters, and the question is find the angle of elevation. Elevation rises up from the horizon. So here's your angle of elevation. They want us to find that. I'm going to call it angle theta. So let's practice. If you put your finger or your pencil right here on theta, let's figure out what trig function we would use. Here's our right angle, so this is hypotenuse, and if you're sitting at theta, this would be opposite and this would be adjacent. So we don't need h at all. We're trying to find the angle theta, and we only have a 15 and 9.3. So let's go with the trig function. Let's write them all out here. Let's go with the trig function that uses O and A, because that's the ones we've got. We've got an O and we've got an A. That would be tangent. So tangent of theta should be O over A. Let's fill in everything we can. We're looking for the angle, so I hope you're getting good at this now. Anytime you're looking for an angle, that's when you'll use that inverse button on your calculator. So it's actually really easy. O is 15, A is 9.3. If you'll simply pick up your calculator now and type in the inverse tangent of 15 divided by 9.3, you will be done, because that will give you theta. You should have that theta is approximately, it said round to the nearest whole degree, so I believe that's 58 degrees. I had a 58.2. Okay, let's do another one. Once again, drawing the picture can be tricky. A meteorologist reads radio signals to get information from a weather balloon. So here's my little weather balloon. I'm sure it's going to be lovely. It's up in the sky. The last alert indicated that the angle of depression of the weather balloon to the meteorologist. So he's standing down here on the ground. So there's our angle of depression, kind of, sort of. Let's make sure we draw that right. So let's get the rest of the picture drawn in. The angle of depression was 41 degrees, and the balloon was 1,810 meters away from his location on the diagonal. On the diagonal indicates that 1,810 belongs right there. To the nearest meter, how high above the ground was the balloon? So they're asking us that x, the height. Now let's figure out where to put that 41 degrees. It's an angle of depression. So many people are tempted to write 41 right there, but it is not right there. An angle of depression comes down from the horizontal. So that 41 degrees belongs right there. That's the part that people tend to screw up the most. Now, you can either draw in the triangle right here and put an X. Sorry, that's a bad straight line. Put an X right there and work on this top right triangle, which is mainly black. Or you can work on my red triangle and just move your 41 degrees down. Remember, they're alternate interior angles, down to right there. So I'm going to do that. I'm going to work on the red triangle. So if I put my finger sitting at 41 degrees, I'm working with, this is the opposite side, and this is the hypotenuse. So who uses O and H? Sine does. So I want to do the sine of 41 degrees equals O over H, so that would be X over 1,810. Now we're solving for a missing side, so this is where you turn it into a proportion. Our cross products will be 1 times X is 1X. Sine of 41 degrees times 1,810. Punch that straight into your calculator. You should get something around this. To the nearest meter, I had done to the tenths, so to the nearest meter would be 1,188 meters. Okay, let's keep going. Lovely. All right, let's try to draw example 3. They get tricky on the picture, so the drawing's going to be the part you need to make sure you go back and try to understand why we draw it the way we did. So a sonar operator on an anchored cruiser, so that means here sits our little cruiser. Mine looks more like a sailboat. And he's anchored, so that means he's not moving. Detects a pod of dolphins feeding at a depth of about 255 meters directly below the boat. So here's 255 meters. Here's our dolphins down here swimming. All right. If the cruiser travels 450 meters to the west, so it's going to move this direction 450 meters, and the dolphins remain where they are, what is the angle of depression from the cruiser, because the cruiser is now over here, to the pod of dolphins? And also, what is the distance y between the cruiser and the pod? So we have to find the angle of depression. We'll put that right here for now and double check that that's correct. I'm calling that theta. And also, what's the distance y between the cruiser and the pod, so between the boat and the dolphins? We'll call that side length y. And here's our right angle. Now let's just double check. I put that theta right there for the angle of depression. Double check with me. Ask yourself, is that the angle that's coming down from the horizon? Yes, it is, so that we've put that in the correct place. All right, so we've got to do several different things. I'm going to find theta first. And anytime you're trying to find an angle, you're going to be using that inverse trig button on your calculator for whichever trig function you use. I can't use that y because we don't know it, but I can totally use this 450 and 255. So when I'm sitting at theta, this is adjacent, this is opposite. The trig function that uses an a and an o, but in the opposite order, would be tangent. So if we do the tangent of the angle we're looking for and set it up as O over A, we'll have it right. So tangent of theta should be opposite 255 over adjacent 450. Tell your calculator to do the inverse tangent of that, and that will be theta, which is rounded to the nearest degree, about 30 degrees. All right, so we have found the angle of depression, 30 degrees. Now, you can use any trig function that you want because you have all three sides now in one angle. You could use the Pythagorean theorem to find y. You do whatever you'd like. I'm going to do if you do Pythagorean theorem, it'd be 450 squared plus 255 squared equals y squared. I'm going to choose another trig function that just involves y, which happens to be my hypotenuse. So I'm going to choose the sine trig function. And I'm going to go with that sine of 30 degrees. Sine of 30 degrees is O over H. So sine of 30 would be 255 over H. You can call it H, or I'm going to call it Y, since that's what it was called in the problem. Turn it into a proportion, and you'll have 255 equals the sine of 30 times Y. So I'm running out of room here. I'll need to divide out that sine of 30 degrees. You can do all this, write it all before you go to your calculator. Now go to your calculator and simply type in 255 divided by the sine of 30 degrees. You should get rounded 510 meters. So we have found theta and we have found y, so we're done with that. All right, there is no example 4, but we will be having our test once we have all this taken care of and you've done this assignment. So please make sure you're coming in now rather than waiting to test day or after. And of course, before your test, get all your missing work in so that if you do need to retake, you're ready to roll. Thanks, guys.